good morning, everybody. Super, very nice. A very good morning once again, and a very warm welcome to all our customers and partners who have joined us this morning. Ladies and gentlemen, I am Nicole Adams, and it's my absolute pleasure to be your host this morning. Velankani Group is a diversified organization driven by innovation, sustainability, and customer-centric thinking. Now, with a strong presence across real estate, hospitality, electronics, and precision manufacturing, the group is known for delivering quality-driven, future-ready solutions that create long-term value for businesses and communities alike. Now today, ladies and gentlemen, the spotlight is on data centers. Now we are here to showcase Velankani's OCP racks, a fully integrated end-to-end solution that is designed, engineered, and manufactured in India, reflecting both global standards and indigenous capability. All right, so we have Aditya on stage. Give it up once again, ladies and gentlemen. Please put your hands together. Over to you, Adit.
Hello, thank you everyone for coming out today. Good morning. We are here to present to you our data center solutions, both in servers and in data center infrastructure. It's becoming a very important thing for India going forward to have a completely indigenized data center manufacturing process. And we believe at Velankani, we are leading the charge towards making India independent in its data center needs. To first talk to you about our server solutions, I'd like to invite on stage Mr. Vibhor Iyer, who's the head of our power electronics division.
Welcome. Myself, Vibhor. I'm going to start the presentation by talking about servers. Servers are heart of any of the data centers which run in variety of segments, be it an enterprise data centers or be it an AI compute data centers. Servers is the basic building block of the data center. This is the roadmap which we are going to talk about. Velankani's journey started by making servers for enterprise solution, that which we call as generation 2 servers. Then there was a natural progression as the industry demanded that we move from enterprise servers all the way till AI and compute HPC servers. We are having ready products in generation 3, generation 4, as well as generation 5. The generation 6, which is a pretty much compute-heavy servers for AI and other applications, are currently under development. We would like to know that all these servers are designed and made in India. Form factor. Server comes in two different form factor. One is a 19-inch form factor, which sits in an enterprise rack. The second is a 21-inch form factor, which sits in AI compute and heavy-duty racks. The servers are of multiple sizes. Current product which we are having is 1 OU as well as 2 form factor servers, which are pretty much dense servers with high TDPs and all. The servers, generation 4 as well as generation 5, are designed to cater AI workloads. When I say AI workloads, any kind of compute-heavy workloads, like you can run an engineering simulation, you can run a large language model, you can run all kinds of compute, you can run any kind of applications which are AI dependent. Talking about features, all our servers which we have developed is developed on AMD Milan chipset, AMD platform, starting with generation 3, which is on Milan, AMD generation 3, generation 4, which is on Genoa, generation 5, which is on Turin, and generation 6, which is currently under development, is on Venice. Cores. You take any server, more the cores, better the parallel computing in all these servers. The journey started with 64 cores, and in generation 5, we are at currently 192 cores. TDP, the total power the server takes. It is started with 280 watts, and generation 5 is 500 watts. Coming about memories, so we do support NVMe as well as SATA. SATA is an older version of memory. NVMe is a pretty much newer version of memories. So generation 4 as well as generation 5 supports NVMe. We have our own board management control software as well as a proprietary hardware which basically powers the server and basically gives a sequence of how the server should power on. Features of the memory. We have basically two types of memory, DDR4 as well as DDR5. Memory capacity started with 4 TB in generation 3. We are all the way right now till 12 TB in generation 5, and we plan to wish to go for more in generation 6. Memory speed 3200 megahertz in generation 3, and in generation 5 is 6400 megahertz. Number of memory slots 32 in generation 3, 24 in generation 5. Now, if we deploy or commission any of these servers in any of the data centers, the server has to work with variety of applications. Now, talking about applications, these applications can be either running on a Windows platform or it can be running on a Linux or equivalent platforms. So, our servers are qualified for Windows, Linux, Red Hat, CentOS as well as Ubuntu. We have an active certifications and our servers are compatible with all these platforms. Why Velankani? Now, if we take any server or any data center which are of national importance, by national importance I mean, let's say the data which we are currently having doesn't reside in India. Most of the data is overseas. Now, if India wants to excel in these kinds of data centers, the server has to be first indigenous. Then the server has to be housed in a data center which is indigenous. So, Velankani's initiative is towards design and developing a server which is completely indigenous. We are having 55% local value addition, and the technology is pretty much proprietary, starting from hardware, firmware, DC SCM, BMC. Also, we do have our entire box build, where we make end-to-end solution starting from the design to the PCB, PCBA, chassis, entire integration, testing and so on and so forth. The entire thing is done in-house. Use cases. Now, right from your phone which we are using, let's say we are using an email, we are using WhatsApp, we are using chats, we are playing any games. There are pretty much all the use cases, like starting from artificial intelligence to media and entertainment to virtualization to simulations to HPC to heavy compute load. Our servers finds the way there. So these are pretty much all the use cases which our server covers. Now I would like you to introduce to our colleague, Mr. Kumar Narayan. He is going to speak about manufacturing of servers.
Greetings, good morning, and a warm welcome from my side. My name is Kumar Narayan. I would like to briefly introduce Velankani's capabilities on the server manufacturing that we have put up over here. The basic core manufacturing process is basically designed into 12 levels of assembly, where Velankani has put up the complete capability right from level 1, and very pleased to let you all know, all the way to level 12. So the capability basically talks about level 1 to level 3, which is basically putting up all the mechanical components into the server, where we have the mechanical parts, we have sheet metal parts, chassis, all that being put together in one framework. So we call these steps as basically level 1 to level 3. From level 4 to level 6 is where we interface the mechanical server with integration of electronic add-on cards, power supply cables, host of other add-ons to the server chassis. These steps become from level number 4 to level number 6. And then we get into level 7 to level 9, which is basically interfacing of the CPU, the memory, the hard drive, putting up all the components together which are critical for the server to function as a complete entity. And then once the complete level 9 is put into place, we have a basic test of the server, and which ensures that the product is completely meeting specifications as per the design. And then we get into level 10 to level 12, where we have the finishing the application OS and putting up the complete rack into place. So pleased to let you know that Velankani, with its factories, which has put up a complete capability right from level 1 all the way to level 12, so which is completely done up at our factories. Like to introduce you on the core part. Like any electronic product, the PCBA is a very, very critical component for the electronic product. From the servers, it's no different. The electronic PCBA is one of the core and the essential part of the product for it to function. But there are key differences which come in ensuring that the servers get built with very high reliability. And with the process criticality which comes into play with very specialized machines, which is what Velankani has deployed with fully automated Industry 4.0 compliant machines. And when I say that, we have screen printing process, which is the start of the process where the solder paste gets typically applied to the board. And then we have it being complemented with inline solder paste inspection equipments, which ensures that the printing process is to the desired level in terms of the accuracy level, in terms of solder paste, which gets deposited in each and every joint. It's very critical to ensure that the right amount of solder paste is being deposited on the board. And then we complement it with the pick and place process, which is highly automated and extremely precise and accurate equipments capable for manufacturing with the sort of accuracy levels which are required. And then we have complemented it with pre-automatic optical inspection equipment, which ensures that the component placement on the products are to the desired specification and ensure that there are no defects during the placement process. So the AOI is ensuring that no defects get created during the manufacturing process, which is completely inline. And then we have reflow ovens, which are operating with an inert environment of nitrogen, which ensures that there is very high reliability on the soldering of the joints, which is what we go through from the reflow process. We have post-reflow AOI, which ensures that the product is again 100% inspected after the reflow to ensure that there are no defects during the manufacturing process after the soldering has been completed. And the step till the post-reflow AOI ensures that the surface mount technology part of the server product has been completed. We then get into the through-hole technologies with the selective soldering, which is again with nitrogen, which ensures that there is very high reliability for all the critical components like odd form parts, connectors, which gets into the servers. We have press fit technology, which also takes care of which takes care of contactless solder, which is again used in some of the specialized connectors which goes on the servers. Complementing that is the X-ray, which ensures that every product that we build gets into a full inspection at the 3-dimensional level with computer tomography to ensure that there are no defects during the soldering process. We ensure that there are no cracks on the solder joint, which is again very important for us to ensure that we have a highly reliable process which is getting established. We then complement the X-ray with in-circuit testers, which ensures that the complete functionality of the product is tested with analog and digital test, which ensures that every component which is getting into the server is being tested and complying to specifications. We just don't leave it at the in-circuit test. We complement it with the complete board functional test, which ensures that the board is powered up. It does a complete validation for the product design from the PCBA perspective to ensure that the complete specifications are tested from the fans, from the BIOS, from ensuring that the motherboard is functioning to the intended specifications. So this completes the core part of the PCBA manufacturing process. I would like to take you to the next slide, which gives you an overview of the box build process, which is where we discussed in our earlier slide from level 1 to level 12. So these steps are from level 6, once the server is actually built. It gets into the main system chassis where the motherboard gets assembled. And following these steps, we have installation of fans, riser cards, power supplies. All the modules get inbuilt into the server. And then we have a complete functional test of the server, post-completion of the server from the end component perspective. So that's the end of the server which gets done. And we then follow it up with the critical test process, which follows the box build assembly. servers becoming a very core part for high reliability, which is the need of the hour, ensuring that it is like a component which gets built with zero tolerance to failures. We ensure that each and every server that we build gets through rigorous testing at the factory. The post-assembly process, we have something which is called as the configuration system test, and we have the extended system test. So configuration system test that we have is basically used to validate the hardware and the software, which is what has been integrated onto the server. So we call it as the test of the server from a configuration perspective, where all the SKU components which is built into the server gets validated. We test the functional layer specification of the server gets tested. We check for the fans, we check for the memory, we check for the basic functional aspect of the server during the configuration system test. We have BIOS, we have software upgradation, we have the BMC test, we have the ME and the FRUs which gets tested. The test time typically for the CST is about approximately 15 to 30 minutes, where all the core functionality of the server gets tested. And subsequently after that, we have something which is called as the extended system test, which is where we do a complete stress test of each and every server that we build. So what it does is it goes through a rigorous round of stress test on the CPUs, the memories, the power supplies, to ensure that all the components are getting tested to the intended specification. And this test is typically about 12 to 16 hours, which is what it takes for the extended system test. Post the rigorous testing that we do, from the CST and EST, it ensures that the server is completely built to the required configuration and completely tested to ensure that it meets the specifications for which it is designed. So that's that from the server testing perspective. And any questions, more than happy to know on that.
Hello, I'm Rudramuni. Can you talk about what kind of security-related tests are we doing at the factory or during the engineering?
So, as far as the security level is concerned, there is only one part of the server which talks to the external environment. That is currently also been, the plan is to, that is the NIC card, as far as the security is concerned. That also we plan to get inside. And as far as the security is concerned, all the components which goes inside the servers are pretty much free from the land border clause. We can say that we don't use any of the components which comes from any of the neighboring nations. And as far as the testing and security is concerned, Kumar will add on top of it.
Yeah, basically the entire test is getting done in a complete secure network. So the test that we discussed about the CST and the EST ensures that the test network and the scripts which are running on the servers are completely run internally inside the secure network. There is no data exchange which goes in an external environment.
So just to add on, more interested in once the server is ready for shipment to the customer site. Now, during the transshipment, there are enough number of instances worldwide where it can be manipulated. That means the BIOS that you have put in should not be compromised when they power on at the customer site.
So for that, typically all the products which we ship out to the customer comes with a seal, a lock seal, which locks all the end of the chassis. For example, the clear instruction which we give to all our customers is, if we are deploying our servers to any of the data centers or any of the data center facility, if that box seal is found to be broken, it is time marked before it leaves the facility. So if it is open, then pretty much you don't access the server. Answering the question of the BIOS gets accessible only after the first boot up. So for the first boot up, before the power supply ships, we have a complete chassis which is going to protect my server from any kind of malfunction for that matter. If the server is received on the site in a sealed condition, it is safe, and we give an end-to-end visibility of the supply chain right from the initial assembly to the time the server reaches. That pretty much ensures that there is no tampering on the BIOS or tampering of the hardware or adding any extra hardware on the server which can cause security level of issues. Thank you.
So I've seen like there is a CSI testing. So is there any evidence at the vulnerability management of any test like you perform at the deployment time. So any vulnerability management or any secure bill of materials, because you might be interacting with a lot of vendors to provide each of the libraries. So how do you manage the vulnerability management for each of the components at the component level?
At the component level, so there are 3 types of components which are there in any kind of servers, be it an active components, passive components, and network components, software level layer. On the hardware side of the components, we pretty much ensure that I can say that the servers which we are having has nothing from any countries which India risk at. 1. The hardware side is taken care of, be it active or passive. As far as the testing of the server is concerned and the initial boot up of the server is concerned, everything is on something called as board management control. The board management control software which we are having is proprietary to us. It's our own software which with minimal or almost no interactions from the external world. That ensures safety on the software testing side too.
You are pretty sure for your proprietary, so there is no tainted configuration should be coming from the external side.
Yes.
Okay, thank you.
That is taken care before the box build itself. When the PCBA is placed on the chassis, this is taken care of.
Okay, thank you.
You listed a set of software OS that you support, Windows to Ubuntu and CentOS and all that. Now, you didn't talk about the virtualization, say from VMware or any other open source also. Do you support them or how do you?
We are actively working with VMware and hopefully very close. We are under certifications with VMware. Once the certification is over, we will be supporting VMware too.
Okay, fair enough. Some of the workloads, which from a customer point of view, they do expect certain performance test results to be published. I'm talking about from a, say, math computing or number of VMs that you can support and things like that. Has there been an effort to do some of that performance testing and publish at the OS layer or beyond?
So we do 2 kinds of things. One is the performance testing on the hardware as well as the performance testing, and we do provide an end-to-end visibility to the customer because let's say we provide it for any of the strategic applications, end-to-end visibility is provided and the entire, once the boot up happens, these data is visible to the customer also at the OS level. Also we do give a standalone report along with the box for all the testing and other things.
Surely I'm asking about the benchmark testings, which are the industry-wide benchmarks that are there, that are used by the customers to compare.
Yeah, so right, we do have a benchmark testing setup in our factory, and pretty much we do all kinds of benchmark testing. If the customer comes back and asks for any extra testing, we are flexible enough that we do conduct that testing before we ship out the part out to the end customer.
Fair enough. Talking about the manageability of a server. So what kind of a capability has been built in at the element level or at the rack level? Because you're talking at the data center level.
As far as managing the server at the rack level and the data center level, we are going to cover this in the subsequent slides, where we do provide end-to-end solution in the data center, starting from the PCBA to all the way till servers. Then comes a little bit wider, racks, bus bar, power shelf, power supply, the infrastructure which goes inside the data center. So we do have we do have a capability of making an end-to-end offering to the customer, thereby giving a complete aspect and thereby covering the entire aspect on the manageability side also. I'll cover that in the subsequent slides.
Hi, Vibhor. Good morning.
Yes, sir.
So we are a component supplier, for some of these power supply units, right? So what I want to understand is, currently we work on the typical AC to DC, then DC to DC configuration, right? So do you think, the high voltage DC, architecture is going to come to India anytime soon? And being a, prominent player in India, can you like push the government to things like that, the new trends in the industry?
So I would like to just say one thing, that everything in the world which we are seeing right now works on DC, most of them. Okay. So high voltage DC is the next transition, and we are actively into that. Then the next slides are going to cover about the DC distribution, right from outside till the POL, the point of line. So we are going to cover that also eventually. But yes, we do advocate strongly on data centers which are running on DC rather than on AC, because that's where the transition is going to happen. That's where the need of the hour is. That's where efficiency is going to come.
My question was also like, you being a very predominant Indian supplier, right? So can you push the government, right? Are there any ways of pushing the government to these kind of newer technologies?
If you bring an efficiency perspective to it, and if you ensure that the changeover happens pretty quick, which is not happening currently in the AC powered data center, then that's what we are advocating. Then pretty much the transition is going to happen. Up until now, we have spoken about servers. Now, these servers has to be housed somewhere. Now, these servers reside in a data center. Velankani Group makes infrastructure which goes inside the data center and which power, in the end of the day, powers the server. Now, this is our flagship product, which we call as OCP ORv3 Server Rack. This is where you can see this is OCP ORv3 Server Rack, and that is the other OCP ORv3 Server Rack. This one is with manifolds, which is liquid cooling compatible, and that one is an air-cooled rack. Our product offerings start from rack, busbar, power shelf, power supply, accessories which goes inside with it, be it rail kits, wire assembly, cable harnesses, and everything. In subsequent slides, I'm going to talk about this in a much broader way. Also, along with this, we have one of our products in enterprise segment that is kept on the display outside. So that is on the enterprise racks. Now, starting with the rack, the current rack which we are having is an OCP ORv3 compliant rack, which is on a 21-inch form factor, 44 OU. Basically, it can house IT devices, 11 OU each, 44 numbers. Now, these are heavy-duty racks which are designed to cater payloads till 1.4 tons or 1,400 kgs to 2,000 kgs. These are liquid cooled ready racks. This is right now air cooled, and this is liquid cooled. This is the rack which you are seeing. This entire rack was designed, manufactured, and developed in-house. What goes along with the rack is busbar. Now, as and when we are going with more and more IT loads are increasing and AI compute is coming more and more into play, power which these racks demands are huge. Now, in traditional enterprise racks, these servers are powered using traditional power supplies where one server has two power supplies, and they are basically on a distributed level. The transition which industry has made is to power the entire rack using a single bus bar, where power comes on a central level. So this is a bus bar. Currently, we are having product range in 1600 amperes to 2000 amperes at 54 volt DC. And we are also in development for making liquid cooled bus bars. Power shelf. The power which goes inside the server rack, the power shelf houses the heart of the rack which gives the power. That's the power supply. Now, if I'm saying one power shelf has 6 slots, and these 6 slots has 5.5 kilowatt per slot. The industry is transitioning towards 5.5, 8, 12, 24, 27 in the same form factor. And it is peak load resilience. Now, talking about power supply. So this is the power supply which is currently under final testing. So this is the power supply we are having. So the power supply looks internally something like this. The entire design has been done in India. We can pretty much say that as far as the local value addition is concerned, we are 70% plus in local value addition. So this basically takes AC input and converts it into DC and give it to the bus bar. These power supplies currently comes in multiple variants. Currently, what we are currently testing is a 5.5 kilowatt power supply. 8 kilowatt, 12 kilowatt, and other supplies are coming pretty soon. DC-LC manifolds. Now, as and when the loads increases, all the servers, basically the basic AI compute servers, should not be air-cooled. These should be liquid-cooled. If I am saying liquid-cooled, what goes inside liquid-cooled is at the very first level are the manifolds, which goes and sits inside the rack. The first model of the manifold is kept here. What connects to these manifolds are the cold plates. Now, these cold plates go and sit inside the server. The cold plate which you are currently seeing is on a 4-socket as well as on a 2-socket variant. These are the 2 cold plates which we are having for variety of TDP values. Again, on the cooling side, what we realized is that take any data center, the IT part of it is just 10 to 20% of it. And there's a lot of engineering which is involved in powering these data centers. Now, as the workloads are increasing, we need to cool it. So we have developed our own coolant distribution unit. It is again under final testing right now. It is based on a Google's architecture of Project Deschutes. It can take a heat load of maximum 2 megawatts at 3 degrees Celsius variation. It can do 500 gallons per minute and 80 psi available pressure. It comes with a redundancy of something called as N+1. As we have a redundancy in all these power supplies, there are redundancies in CDUs too, where we are backing up with an N+1 pump, where if one pump goes, the other pump can take over. And both these pumps are on fully redundant power feeds. This, hopefully by end of this quarter or eventually we will be into final testing for these. Now our roadmap. This is how the current Indian data center looks like, if you see. Today, we are traditional servers, which is 20 to 30 kilowatt per rack. These are air-cooled, and the flop computes, if I say in terms of kilowatts, are 8.75 teraflops per kilowatt. These are normal storage racks or enterprise racks which are used for normal storage applications. Where are we transitioning? We are transitioning to tomorrow, which is here, which is AI and HPC data centers. These are the racks which you are seeing are AI and HPC driven racks. It can cater power from 100 kilowatt all the way till 1 megawatt. They are liquid cool compatible because after 100 kilowatt it is the liquid cooling way. And see the transition it is making from 8.75 to 785 teraflops per kilowatt. That is the transition which we are making. We are a proud member of Open Compute community, and we started as an initial member, and now we are defining roadmaps along with Open Compute Project on how the data center for 2027 and ahead, 2027, 2028, 2029 and 30 should look. So we are on the architecture team defining these roadmaps. Now data center architecture. Now just to give you a brief, if this rack and this rack, if both these racks are fully loaded and they work on full power, it is going to take the power 2 times of what this entire hotel building takes. For example, this entire hotel, let's say, takes 100 kilowatts or 150 kilowatts. These 2 just racks alone is going to take 300 kilowatt plus. So that's where the world is moving, where more and more power is going to come and be compacted in a very small form factor. Now for that, if there's so much power which we are talking about, thereby comes efficiency. So the roadmap should be such that we have to make a leapfrog transition from a lower efficiency to a pretty much higher efficiency. Right now this is how the power flows. We start from 11 kV grid. It is given to a transformer, which converts it into 440 volts 3-phase AC. Now that 440 volts 3-phase AC is given to this rack. This racks do an AC to DC conversion and gives a 48 to 54 volt DC output, which goes and powers the bus bar. The data center efficiency here, the total data center efficiency, right from the grid to this is 78%. When I said 78%, my power supply is running at 96% plus. But the transmission losses are there, from 11 kV to the transformer, to the air circuit breaker, to the distribution losses, to the point the power comes to the rack where it becomes usable. The efficiency is 78%. That's where we are 2025, 2026. In 2026, we are moving towards, we are making a transition. By the end, we are increasing the data center efficiency by 4%. What we are doing is, we are taking 400 volts three-phase AC. This becomes my sidecar. If I say sidecar, 400 volt three-phase AC comes here, and that generates 400 volt DC. That DC goes to and powers 10 such these kinds of racks. So basically, one sidecar powers 1, 2, 3, 4, 5, 6, up till 10 such racks, increasing the efficiency to 82%. The next transition, where we are the key architect on that, is something called as solid state transformer. If I say solid state transformer, I am totally eliminating the low frequency transformer, where we are taking 11 kV from the grid, we are giving it to a solid state transformer. Solid state transformer is making it convert to 800 volt DC, and that 800 volt DC comes and directly powers the rack, which gets converted into 54 volt DC, and the power flows. The data center efficiency here increases till 94%. That's our plan for 2027. On the same grounds, we are building, as the first live prototype, we are building a 1.5 million square feet DC distribution building here. That will be on similar lines on how the future data centers are going to be powered. I spoke about today's architecture. It's 144 kilowatt per rack. This is the sidecar architecture, which I just spoke about. This is the next generation DC distribution. Now, why DC distribution? Data centers consume most of the power. 50,000 numbers of NVIDIA Blackwell would annually save 150 crore worth of electricity if data centers are powered the right way. 50,000 NVIDIA GPUs, if they are fully running, is going to have this much amount of electricity consumption if we transition from the current way to the new way of powering, just by increasing the data center efficiency. The architecture which we are proposing is low in maintenance cost. And why these kinds of compact architecture? Now, if you see, these data centers are typically located in remote places. When I say remote places, if I want data in electronic city, and I'm coming that I want a compute heavy data, which is going to take, let's say, 100 megawatts worth of power, the natural transition which is going to be there, which the data center player is going to do, is place it outside Bangalore. If the servers are housed very far off from the city, what happens is, by the time the compute comes back and reaches you, the inherent latency increases. Now, if you want a better experience on this AI segment, more and more data centers should be closer to the end user. For example, if end user is in electronic city, it is better that these AI data centers reside in electronic city, so that the data latency is pretty much low. Now, on an urban landscape, if real estate is everything, now all these racks are compact. For example, this rack and this rack added together can pretty much cater all the compute requirement for the entire electronic city companies which we are having here. Our leadership in DC distribution, we are an active OCP member, and DC distribution final specifications we are actively participating, which are to be released in 2026. And our prototype commercial building on DC distribution center will be ready by 2026 end or similar time frames. Thank you. Any questions you guys are having?
Good that you talked about the data center efficiency. Now, the term or the usual metric that is used is a PUE, power usage effectiveness. It has to be supported all the way and the overall at the data center. Now, the data center designer, you have to work and collaborate with them to make sure that at the time of deployment, the PUE is achieved. Otherwise, practically, it is not yielding what you are looking for. right? Is there such a collaboration, and or is Velankani also going after the data center design?
We are going after data center design too, where we are working with an end player to bring that change, that we increase the level to whatever things we need. The faster we will transition is one, the natural courses for us will be to design our own data centers and deploy it ourselves. So that's where the awareness will come from. Also, we are talking to many of these system integrators and we are educating them on importance of DC distribution. Yes.
So, what is the level of redundancy at various levels you are planning? That is, at the power supply level, at the server level, board level, whatever. Both security, of course, you already answered, but about redundancy, can you elaborate a little bit?
Now, if we call about redundancy, as you have rightly said, we need redundancy first in the power level.
Exactly.
So, for example, the power shelf which we are having has 6 power supplies.
Okay.
Now, based on the customer need, customer can make it 5 plus 1, where 5 is the main, 1 is the redundant, can make it 4 plus 2, and make it 3 plus 3. The lowest he can go is 2 plus 4, where 2 is main, 4 is redundant. For example, if the data center is installed at super strategic locations, 2 plus 4 is what we are looking out for. That is on the power level. One more redundancy which goes inside the server level is fan. Now, you will be surprised that in a heavy duty IT equipment like a server, the first thing to fail is a fan. Okay, so that people have transitioned from liquid air-cooled data center to liquid-cooled data center. So their way, there are no moving parts which are there inside the server, making the server more resilient and more prone, less prone to failures. Now comes, if we are liquid-cooled, then second level of redundancy is what we need to maintain is on how the liquid is being flowed inside, so that the liquid should not come in contact with any of the IT loads. For that, we have come up with a methodology where all our chill water distribution unit or coolant distribution units are made with brace type heat exchangers, almost ensuring zero leakage. That's where the redundancy which we are building, and the liquid should also not fail. So we have a redundancy on the CDU also, where we have n+1 redundancy, where one pump is the main and one pump is the backup. That ensures that pretty much near 100% uptime for the loads.
Hi, my name is Shivyogi. I mean, the data center requires a lot of power. And though Karnataka is power surplus, but we see a lot of these, shutdowns in the summers. And how do you see, I know KPDCL can put more the bus stations, substations, but how do you actually tackle this power supply requirement? Thank you.
Now, if you are talking about data center power supply requirement, first power has to be there. So that is given. Now, let's say for some instance, there is a downtime. What we are having is a downtime, something like in DC distribution centers. Moment the power goes down, the first thing which comes up in all these heavy compute racks is battery backup unit. It is called as BBU. Battery backup unit powers these servers for 2 to 3 minutes. Now in 2 to 3 minutes, your backup power should come and kick in. Now backup power can be either via diesel generator, if it is a AC distribution center, or it can be via the battery energy storage system, if it is a DC distribution center. Now keeping both of things together, the response of the battery energy storage system is more high, because moment the power comes in from a DG set, there is an inherent latency in the power. So the next level is, first power has to come from the grid, but as you are saying that there are abruptions in the power, that can be taken off by the energy storage elements like battery energy storage systems and further, which comes at very lower footprint compared to a diesel generator. That ensures that data centers are up and running.
Hi.
Hello.
I'm working for AMD. I have question related to the industry shift is happening now, right? Like traditional servers are moving towards the AI-based servers, right? So that involves the head node that using the processor, CPUs and GPUs together. So most of them are looking as kind of a complete product. And that's going to be the next kind of the growth market, right? Because everyone is shifting. If anyone you go and ask, okay, they want to buy a server, they'll be checking with you, okay, what kind of AI workload I can
What kind of?
run AI workloads,
Yeah.
right? So that will be the first thing. So then everyone will be moving, like what type of kind of solution this Velankani is planning to have in the roadmap to manufacture such a system, like having a CPU and GPU nodes together, like NVIDIA provides, AMD also it's in plan to provide, right?
So you're from AMD, right?
Yes.
We are already in the generation 5 supports your MI series on the GPU side, where we don't sell to the customer just saying that we are selling the CPU. More and more customers are asking for AI workload in some strategic segments.
Okay.
So we do have all kinds of GPU loads which we support. Currently, we are having GPU loads on PCIe platform. But the ideal thing what we will be looking of is rather than PCIe and a Razer card holding the GPU, the next transition would be the GPU sits on the motherboard itself.
Right. Yeah, that's the ideal one, yes.
That's where we would love to collaborate with companies like AMD to ensure that how this can be done.
Trying to connect the redundancy related question and answer plus with the server manageability. All kinds of redundancies, and if surely you don't want to, ideally you don't want a single point failure, but whether it's a fans or a power supply and any of them, you have the redundancy. Now, when one of them goes bad, it can fall back, but the management software should be able to trigger certain things, okay? This is on the redundancy related manageability, okay? Now there is the power management part also, which is throttling the power based on what is happening at the workload. Now that capability also comes at the server management. Now you can go all the way up to the rack level also, but it comes from the manageability at the server level. Now, power throttling algorithms and every component on the motherboard and the rest of the servers should feed into it. IPMI is one of the specs that's already there. And the overall, when you talked about the capability of the server manageability part is not highlighted yet. Is there something that I'm missing, or manageability is still cooking?
So if you are saying the manageability is not highlighted yet, so let me correct about my understanding of what manageability you are talking about. My understanding is, let's say something goes down in any of our servers, nothing should get corrupt inside the server. Is it what you are talking about?
No. If something goes wrong, it should be able to send an, ideally, advance warning, and subsequently, if truly it goes wrong, an alert. Various variety of alert. This is one part of it.
Okay.
In a production-ready server which is running, what is going wrong or what is happening in terms of moving certain workloads? If for whatever reason the performance is not good enough, or there is a reason to move certain workloads, all that is triggered through the manageability again. Second aspect. The third one is more to do with the patches and things like that. Okay, and that's a maintenance of the server. Could be at the BIOS level, or could be a firmware on a disk itself. Okay, variety of those patch updates constantly keep happening, and that also needs the manageability. So all aspects of the management, not just related to the hardware alone.
So right now on the manageability, I think Arvind have something to add there.
Servers that Velankani Group has built has a fully functional BMC. And the BMC will take care of most of what you're saying. Of course, in terms of doing throttling of the power and all of that depends on what the CPU provides as the functionality, right? So Intel, for example, gives like Node Manager. AMD may have other functionality. So we could always build those functionality. Right now, it may not have the throttling functionality at the manageability level, but all other functionality in terms of redundancy, patching, and all of that is available in the BMC that, the AMD servers that Vibor mentioned. I used to be at AMI, and we licensed some of our technology to them, and Ramki integrated that into the server. So I'm quite familiar that it fully supports everything that you said in the server.
On the server side also, we are building our own PMIs, where transition started from RMU, and from RMU we are transitioning towards PMI now, with the entire manageability of the individual rack components levels, as well as what is the health of everything inside the server is also taken care of.
Hello, Vibor. So, especially in case of HPC end use, like from some of the strategic accounts in India, like a government organization, they prefer to have workloads locally done because it's more strategic. So is there any push from the government to localize the design, manufacturing, and deployment completely by, eliminating the risk countries? So any push from the government in this regard?
There's definitely a push from the government in that regard, where the entire thing, first thing is the data should be local. But whatever IT load and infrastructure which are going to house that data also should be local. So there's a big push towards that aspect of complete indigenization in data center. This involves starting from what goes and powers the data center, racks like these, to all the way till the POL, which goes and, talking about from the Infineon's perspective, goes and powers the server to the last mile. 0.9 volts is generated from your POL switch. The end-to-end indigenization is what government is also looking out for.
Does your roadmap include data center supplies only or complete data center management?
Currently, I think only supply, and eventually if the market builds up, we will manage also happily. For example, if Elsita comes and say that build a data center for us and manage, we will be the first one to raise our hand and do it.
Since indigenous part is highlighted, is there anything on the roadmap to make these servers as ruggedized from a mechanical and all aspects of it? Right? At the end of it, if you have to be a supplier to the defense, and a variety of expectations there are huge. Now, that is not talked about, so generally bringing that up.
Let's say we are talking about the ruggedness which goes inside the server and which is going inside a defense application. Now, defense, there are two kinds of servers. Defense for an offensive application and defense for a defensive application. First and foremost, the ruggedness on the chassis level, we build our own chassis. We have not yet supplied anything on the defense side, but yes, the natural progression is that we certify our chassis for JS Penta 5 standards, where whatever plating which we do, right on the chassis, right from the metal to zinc and zinc nickel plating which we do, should adhere to JS Penta 5 environmental standards and those IP standards which they demand. That is the first natural progression. We are not doing these kind of testing as of now for defense applications, but definitely we are doing all the standards which are needed for normal commercial data center. On the chassis side, this was a thing. Second, on the board side, we do have a plan in place where our entire hardware is pretty rugged as far as the board is concerned. But now if I am going for an offensive application, I have to replace it with the mill grade parts, which I am not having as of now yet. Hopefully next Data Center Day, or eventually we will talk about data center in space also. That's our next level of ruggedness which we are talking about. That's what the initial transition is, the natural progression is going to be.
Actually thought I'll ask a question in sync with that part, but I think you kind of answered it. But let me go back and say there are two parts to it. When you look at the ruggedness part, you're looking at the physical ruggedness of the enclosures and systems. But when it comes to your power or the temperature ranges, so most of your components, if you're actually looked at the enterprise data centers, you would not be running your temperature or extended temperature range systems. So are you looking at this to be extended towards that?
See, the components which we are currently having are designed to work at 50 degrees Celsius ambient. But nothing changes much on the design perspective of it. Now, we just need to, if we are doing something on a strategic side where the data center is there, same component on a design perspective has to be replaced with a mill grade component which supports till 150 degrees Celsius. And then we need to conduct a rigorous amount of test in EMI EMC. We need to conduct rigorous amount of tests in environmental standards, and we need to conduct a rigorous amount of tests in other certifications which goes along with it. That will be the thing, natural progression if we plan to build data center for strategic applications. But currently our data centers are designed for 50 degrees Celsius ambient.
Actually, you're looking at data centers which don't move. Data centers which don't move, which sit inside air conditioning units.
Yes, data center which doesn't move.
But I think the question was more from the industrial and defense requirements from an overall systems and extended temperature ranges.
See, typically as per my understanding, defense typically doesn't involve these heavy duty servers in offensive landscape. When I say
don't use the word offensive landscape. Look at it on the purely from, don't use why it is used for. We are a defense company. So when we say that we are a defense country, we would like to defend ourselves. That's how we should look at it as. But
so for that only transition is right choice of components. But I will say the board will remain exactly same. The component has to be scaled up.
Temperatures in India change all the way from minus 40 degrees in Siachen all the way to 60 degrees centigrade somewhere in the middle of Rajasthan. I just want to leave it there.
Yes.
Myself, Arvind from Panasonic. So it's good to see DCLCs being locally developed in India. So how do you see the trend of DCLC? So it will be predominantly based on the AC centrifugal pumps, or it will be migrating towards DC pumps?
It will be migrated towards DC pumps eventually.
It is due to the DC distribution which we
there
are
I think my colleague can answer it. I can see him smiling. But yeah, I'm talking about Srinivas. Okay, so natural progression will be, is a very debatable topic that the machine is a DC machine or an AC machine. So it is DC distribution. A DC motor also works on RYB. So
and also since it's a direct chip liquid cooling, so I believe the cold plate will be placed above the chipset, right? Yeah. So how do you make the chipset to dissipate the power? Will there be any medium between the chipset and the cold plate? So something like heat sink or a kind of grease or graphite material, something like that?
The CPU is lying like this. Now the thing is, the cold plate is going to sit just above on the CPU, and copper is going to make a direct contact with the CPU. Definitely, we are going to add a material before we place the CDU on top of the cold plates.
So the material is going to be some sort of grease, thermal grease, or is it something like indium material, or?
Depends on what kind of TDP you are talking about.
Okay, because now with the current trend, the TDP is increasing a lot with all the AI workloads.
Indium is the natural progression, where at the reflow only we take care of. But there are other thermal pads and other things also which are pretty much efficient on those lines.
Yes. And also you mentioned about the BBU, battery backup unit for the DC distribution data centers. So how do you see the trend? Like we are understanding from various people, BBU plus the capacitor, the super capacitor is going to, the hybrid architecture is going to take care on the backup requirements. So how is the trend on that?
There is nothing like super capacitor per se. Okay, super capacitor is just an architecture of variety of circuits powering it in a certain way. So BBU is going to be your primary backup in the near future, which I am looking. Super capacitors with such high discharge and charge currents, still it is little bit far off.
Okay, thank you.
The question is probably to Kumar Narayan, but more on the factory installation. Now the OS, whatever OS the customer wants, is there a plan already at the factory level to install the OS along with the required license and things like that? Factory installation is what I'm talking about.
Once the system gets completely tested at the factory with the configuration system test, extended system test, we do the hypod test, we do the ground continuity test. So all the safety tests are done. And then finally, when it comes to the OS stack, we do the complete, we have the full-scale capability to load the operating system and ship as per the client requirements. So answer is yes.
Thank you.
Mr. Vibhor, thank you very much once again for that amazing session and for taking through all the questions. And to all those of you who asked questions, thank you very much.